here's my original set of data, 1, 2, 3, 4, 5. What's the mean and standard deviation of that? Feel free to use your list. What'd you get? Mean is 3. What's the standard deviation? I agree. All right, let's look at the first set of data. 3, 4, 5, 6, 7. Now we shouldn't need our list for the rest of this. What would the new mean be? How does the new set relate to the original set? Plus 2. So what's the new mean? 5. What's the new standard deviation? So the new mean, let's see if it's in here. Oh, it's not. Shocking. All right. The new mean is 5. The new standard deviation, that's going to remain the same. That's going to be the 1.581. All right. How about the next set of data? How does it relate to the original? We multiply by 3. So what's the new mean? So we're going to multiply by 3, so we're going to get 9. And how about the new standard deviation? What's that? 4.743. Okay. And how about the third set of data? How does it relate to the original set? What's that? Times 2 plus 4. Do you all agree? What's the new mean? Start with 3, multiply by 2, add 4. That's 10. How about the new standard deviation? A little louder. 3.162. What did we do there? Just multiply. Okay, so there it is. All of it in there. Okay. Influenced by outliers. We addressed this. We started talking a little bit about this yesterday. Medians and quartiles, they're resistant to outliers. Do you understand what I mean by resistant to outliers? Yes, they're not going to be affected by some crazy number. And then mean and standard deviation are sensitive to outliers. Does that make sense too? They're going to be changed based on what's happening in the outliers. Okay, cool, awesome, very good. I'd like you to try something. I'm going to show you a little bit of like a real life example of what we just did. Okay, here's some data. I want you to go ahead and you can work together on this. You might want to write it down. Go ahead and solve those 3 problems. Okay. Got some examples of the normal distribution would be like height is normally distributed typically, weight. There are millions of examples of things that are normally distributed. But the standard normal distribution has a mean of 0 and a standard deviation of 1. We call that the z-score. Okay. The area under the curve, this curve is 1. We want to think about, we're gonna want to compare area and probability. So if the probability of something happening is like 1 is for a certain happening, we want this whole area to be 1. Okay? So the mean is in the center at 0, 1 standard deviation. Most of your data falls within about 3 standard deviations from the mean. Okay? So, we want to find the probability of choosing a value that falls between negative 0.97 and 2.83. So, you're going to need out your orange packet. So go ahead and pull that out. Got a bunch of tables. Yes. And in particular, these two right here that are on page 13 and 14, or it's labeled 13 and 14, are your Z-score tables. And on the page 13, it's all the negative values. And on 14, it's all the positive values. If you look at the top, it's just kind of a picture where the shading is the left. That all makes sense. Yes? So, we're going to use this chart. We're going to make sure you know how to use it. I'm going to show you how to do it on this problem. And then we're gonna take a few minutes to make sure we got it before we move on. But, we want to find this area right here. And this table is always going to give us what's to the left of whatever number. Okay? We're going to start actually the furthest right. So we're going to start at 2.83. So go to the positive side. Now, the 2.8 is down the column, the right-hand column. And the 0.03 that represents this 3 right here is at the top. Look for where the 2 cross. So that'll give you the 2.83. And what number do you see? Everyone okay with that? All right, so we're going to start with 0.9977. Now let's talk about what 0.9977 represents. It is the probability of getting something 2.83 or less. All the way, continued on. So it would be, I'm going to shade it kind of lightly so you can see. 2.83 would be all of this plus all of that. Okay? But what do I really want? I want it to stop. How am I going to get it to stop? I want to, if I subtract out this part that's in blue, I'll have it, right? So now I'm going to go to negative 0.97, which is on the other side. You'll go to negative 0.9, and then up at the top it'll be 0.07. Look for where those 2 cross. What do you get? Point what? 0.1660. Do you all agree? So that's the blue part that I don't want, so I'm going to subtract it out. There you have it, 0.8317. Must be the answer down here somewhere. 0.8317 is the probability that if I just randomly select a value on the normal curve between negative 0.97 and 2.83. 0.8317 or 83.17%. Yes? Now I want to pause here and I want to give you a chance to figure this stuff out. I want to give you a chance to work with these charts, get comfortable with it, okay? So what you're going to do is with your partner, you need a piece of paper out, at least one between the 2 of you. It's fine if you just have one between the 2 of you, it's fine. But what you're going to do is this, we're going to play a game. Here's how it works. Come up here, you start anywhere you want. Flip the card over, it'll say given a normal distribution with mean is 0, standard deviation is 1, and then it'll give you what you're supposed to find. This one says find traveling -3.1, 3.0 or less. So you would draw, I want this picture drawn. Got it? With the shading. Very important, you're not going to want to do it anyway. Got it? Put this down, go back to your seat, find it. Once you find it, if you did it right, it should be one of the numbers up here. That's the next problem you go to. Does that make sense? I want to see the picture drawn for each one of them. And you have to go back to your seat between the two. Go back to your seat to find it. So the orange cards have to stay in your seat. Okay, so you can just send one person up to look at it. The cards cannot go back with you. And if you leave them right at the same spot, then that's nice for everybody because right now they're in order. So if you do this, oh, this is 0.1562, great, it's this, and put it over here. Now it's not in order, and you guys, it's hard for, then you're like, where's 0.1562 is not one of the answers, it's not here, oh wait, it's way down there. Does that make sense? That's no fun. I mean, I don't care, but I don't think it's any fun. So, there you go. If you do it correctly, whichever one you start with, you may want to make note of it. Like if I start with this one, I make note of the fact that it's 0.1075. Eventually, after I've done a bunch of problems, I should get back to it. That's when you know you're done. We're going to make this a competition. The winning team, 1 bonus point on the test on Friday. You know every point counts, especially on tests, yes? But if there's cheating going on with that team, they do not get the bonus point. Ready? Hey, are you two in the back?
Max.
Go.
Max. Who's your partner? No, do you come?
Orange paper has to stay in the seat.
What? Are we supposed to choose partners?
No, you're next to me.
Okay.
Yeah. Started with 0.4761.
We started with 0.2.
Negative 1.32 or less.
Alright, so this, the only real life example of where the mean is 0 and standard deviation is 1. So we talked about the freezing point in degrees Celsius of water. Okay? So I want to find the temperature that corresponds to P sub 80, which is the same as the 80th percentile. It blocks the bottom 80% from the top 20%. So it's going to be a little different this time, what I'm looking for. I'm still going to use that chart, and I'm looking for something a little bit different. Okay, so my mean is 0. Okay, now what temperature, what percent of the temperature should be less than 0? In a normal distribution. 50%. Yeah, everyone okay with that? Makes sense? It's normal, the mean and the median are the same, so 50% are below it. So whatever temperature it is, it's going to be the 80th percentile. Is it going to be to the right of 0 or is it going to be to the left of 0?
Right.
On my graph. To the right, because it's going to be bigger than, so yours is going to be somewhere here. I'm not sure what it is. This is what I'm trying to find. But I know that it's the 80th percentile, which means everything to the left of it has an area of 0.8. So, is it going to be a positive value or a negative value? Positive. So go to your positive chart. Now this time you're given different information. Okay? When I go to my chart, I'm given the area, in other words, I'm given the probability, this to the left, and I need to figure out what number it is. I need to find the opposite of what I've just been finding. So when I go to this, my goal is to find the number that is closest to 0.8000 on the inside of your orange sheet, and find the number that corresponds to the value that's closest to 0.8000. Does that make sense? So see if you can do that. What's the number that corresponds to it, do you think? 0.84, I think, is the one that's actually closest. Degrees Celsius, because we're talking about temperature. That would be your answer. 0.84 degrees Celsius. Now we have a problem. The only chart that they give you on the AP test is the one where the mean is 0 and the standard deviation is 1. But I have a problem because I just told you the only real life example of that is freezing point water. So what happens if I'm talking about some other normal distribution? What if I'm talking about the height of women that has a mean that's more like 63, 64, and a standard deviation that's more like 2.5? How am I going to find the probability I get somebody that is taller than 68 inches? Yes?
Final number and then multiply by 63.
Nope. That's a good idea, but the problem is that also the standard deviation is affected. Okay? Yes?
Multiply by the standard deviation, you have in this case you multiply by 2.5 and add 60.
Okay, so yes, actually you are correct on that. So the z-score is the number of standard deviations above or below the mean that your number is. I can't have a chart for every single mean and standard deviation I could possibly want. First of all, Ms. Burge would like flip out because the amount of paper I would use. In fact, I don't think there's enough paper in the building to even make one packet with all of them in it. And also, obviously you'd flip out when I handed you a paper that was, 3 stories high and said, please carry this around with you. Right? You'd be like, I can't. So here's how we fix this. We've got a z-score. Here's what's great about a z-score. Let's say you take a test. I don't know if you've ever taken a test before. Might have, right? And let's say, now I know this has never happened to you. Maybe you don't do so well on it. And maybe you go home and you tell your parents, everybody failed the test. That was the hardest test anyone's ever taken. Everybody failed it. Don't worry, Mom and Dad. Everyone failed it. I did just as well as everybody else. Have you ever said that to your parents before? Never. Never. So here's what this is going to do. This is going to give you an idea of how you really did. Okay? So when we get our next test, I will tell you what the mean of the test was. I'll tell you what the standard deviation is. And you can get an idea, how did I do in comparison to everyone else in my class? Okay? So you got a 75, but your z-score was, say, 3.2. Well, you probably got the best score in the class. Okay, so you're right, everybody failed it. And I did amazing. Okay? But if you got a 75 and your z-score is negative 2.3, well, you probably did the worst or very close to the worst in the class. Okay? So it's going to give you an idea of how am I doing in comparison to everybody else in the class. Okay? So then you can go home and say, well, Mom, I got a 75. You know what? It's better than everybody else in the class. So, that'll be good. And I doubt you're going to go home and say, well, Mom, I got a 75. It was the worst grade. It was the worst one. But when your mom calls me and says, why are they failing your class? And be like, well, they did worse than everybody else on this test. Right? Then we can have a conversation about that. So very good way to kind of do it. Here's what you do. You take whatever score you're talking about, your grade on the test, subtract the mean from it. Mu is a way to talk about population mean. And then divide it by the standard deviation, sigma. So you take whatever score you want to change. That'll give you a z-score. That'll give you the number of standard deviations above or below the mean, which then will have a mean of 0 and a standard deviation of 1, and you'll be able to use that chart to get your answer. How do we unstandardize it? In other words, how do we solve for x? There it is. All that is a little algebra. Multiply by standard deviation, add the mean. Do you have to know this formula? You do not. You could just plug in what you know and do the algebra every time. It's not a big deal. But there's down. Okay, so let's try something. Body temperature of healthy adults. Normally distributed with mean of 98.2 and standard deviation of 0.62. So my mean's not 0, my standard deviation's not 1. I'm gonna have to do something about them. What's the probability of randomly selecting someone with a body temperature above 99.9? Did you all figure out how to do above when you were doing your value? You subtracted it from 1, yes? Cool. All right, so let's draw a picture. You always like to start with a picture. Sometimes on the AP test, depends on the question, you will lose points for not drawing a picture. Sometimes you will not. I like to draw a picture every time. So my mean is 98.2, typically kind of right underneath it what my standard deviation is. 99.9, is that to the left or to the right of 98.2? To the right. And I want above it, so I'm going to shade to the right. Okay, so let's find the z-score. So the z-score would be the number we're looking for, 99.9, minus the mean, 98.2, divided by the standard deviation of 0.62. What do you get? 2.74. Then you're going to go to your orange chart. Find 2.74. What do you get? 0.9969. What are you going to do with 0.9969? Subtract it from 1. That gives you 0.0031. So there's your probability. 0031. Is that unusual? What's our cutoff for unusual? 5%. So our cutoff for unusual. Is that less than 5%? Yeah, so it would be unusual for somebody's, all of our body temperatures are a little bit different. So somebody who's healthy to run a temperature that's about 99.9 would be unusual. It's not impossible, but it would be unusual. So yes, unusual. All right, find p sub 20. What does p sub 20 mean? 20th percentile. So if my mean's 98.2, is it going to be greater than or less than 98.2? The 20th percentile. Less than. Let's be over here. This is what you're solving for, this little question mark. How am I going to do that? What am I going to do first? The 20th percentile, we want to find 0.2 on the inside of our orange sheet. Find the z-score that corresponds to it. So once you start there, what do you get? 5 points on the inside. What's that? Negative 0.84. We find 0.2, like inside, but you have to go to the negative. So, negative 0.84 is your z-score. Everyone okay with that? And then, are we all right?
Well, the other one's a little closer. It doesn't matter.
Is it closer?
It's closer.
What is it?
0.0002. It's negative 8.5, looks like. Negative 0.85, yeah. Oh, wait,
1977
okay.
and 0.205, okay. We just wanna make sure, because whichever one's closer is the one we wanna use. So negative 0.84 is your z-score. Now we need to unstandardize it. So I can multiply by the standard deviation, add the mean. It's just the algebra of this. Multiply by 0.62, add the mean. What do you get? .68. Does everyone agree with that? Degrees Fahrenheit, so that would be the 20th percentile. So 20% of the people have a normal body temperature that's 97.68 degrees or less. Okay? And then just lastly, here are the intervals for our normal distribution. About 68% fall within one standard deviation of the mean on either side. 90%, 95%, 99, and 9.7. So the 3 standard deviations is 99.7% of our data.